Okay, so to solve a work problem using a rational equation, the easiest way that I know to do this, it's a formula. I'm not normally a fan of formulas, but for this, I like formulas. So I channel my inner Dr. Seuss and call this my thing one and thing two. And then it is the formula that I have is together over alone plus together over alone equals one job. And since it's just one job, I'm going to make, since I have other fractions, I'm going to make everything a fraction. So when I'm doing these problems, I have generally it's two things working together, or words that we're talking about. So it's pools or pumps or computers and stuff like that. It's when you have more than one thing working together to get something done, and they should be helping each other. So your times should kind of make sense. So we have two pumps. We have the old pump and we have the new pump. And two pumps together can drain a certain pool in 3 hours. So that is together on both of my fractions. It is going to be 3 and 3. It's going to equal 1 over 1. If it takes the older pump 7 hours to drain the pool by itself, so that's going to be 7. How long will it take the newer pump to drain the pool on its own? X. All right, so we've got a problem. We've got fractions. We want all the fractions to have the same denominator, or we're going to multiply by the LCD. So we need the LCD, which is going to be the first denominator. And then we look at the next denominator and say, ooh, is it already accounted for in the what I've already written down? And it's not, so we need the x. And then we look at the last denominator and say, do I need that included as well? Has it already been dealt with? And 1 goes into 7, so it is already taken care of. My LCD is going to be 7x. And then if I want the fractions to disappear, I can multiply each fraction by the LCD, and I would call it the LCD over 1. I could also get everything to have a common denominator and then do the arithmetic to combine all like terms, cross multiply, all that. But it's easiest to multiply everything by that LCD over 1. And when we do that, we get things to cancel out. So in this fraction, I have 7x over 1 times 3 over 7. These 7s will cancel out, and I am left with 3 and the x. So I'm going to say that this is 3x. I've got my plus sign hanging out here. And looking at the next one, I have 7x times 3 all over 1 times x. This time the x's will cancel out, and that will be 7 times 3, which is 21. And then over 1, which the ones I don't need to have because anything over 1 is just the anything. And then the last fraction is going to be 1 times 7x over 1 times 1, which is just going to be 7x. So I have this nice little problem to solve. It looks like one of those problems that we've had at the very beginning of class. So I'm going to get the x's together. So minus 3x minus 3x. I get 21 equals 4x. 7x minus 3x is 4x. Divide both sides by 4. Divide by 4. I get 21 over 4 equals x. This is 4 times 5 is 20, and then 1/4. So this is just going to be 5 and 1/4, or 5.25 hours. Or 5 hours and 15 minutes if I really wanted to think about that. So yeah, so that's the general gist of how I do these problems. We can do one more looking at this, solving a work, actually 2 more, but starting with the first one, work problem using a rational equation. We use my same formula, together over alone, puts together over alone equals one job done. This time I have an old computer and a new computer. All right, so my old computer takes 3 times as long to send out the email as does the newer computer. Newer computer is going to be my x. Old computer is going to be 3x. All right, so plus this equals 1 job, and I'll make it over 1. Working together, it takes the two computers 12 minutes to send out the email. So this is going to be 12, this is going to be 12, and in this case, my old computer is 3x, my new computer is x. Noticing what that we have with fractions, you always want to reduce things if possible. It's a good plan. In this case, this first fraction, I can divide everything top and bottom by 3. So 3 goes into 3 once, 3 goes into 12 4 times. So my problem really is 4 over x plus 12 over x equals 1 over 1. Now on the left-hand side, I have a common denominator. I'm just going to combine these things. I could multiply everything by the lowest common denominator if I wanted to and make things cancel out, but I could also just add my fractions and then have a fraction equals a fraction. So 12, this is the same thing as 4 plus 12 over x equals 1 over 1. 4 plus 12 is 16 over x equals 1 over 1. Cross multiplying, this gives me 16 times 1. So 16 equals 1 times x, and I have my problem done. Okay, so it is going to take the older computer to send out on its own 16 minutes, which makes sense. It is going to be longer than those 12 minutes that it's working together. Actually, no. My older computer is not the 16. The newer computer is the 16. So new is 16 minutes. Okay, the old is going to be 3 times 16 minutes. And 3 times 10, so that's 3 times 10, and 3 times 6, so 30 plus 18 is 48 minutes. So the older computer is going to take 48 minutes to send out the emails all by itself. It does make sense because those two computers working together is 12 minutes. Each one should take longer than that 12. All right, then the last one that we're going to look at is still solving a word problem. This time we have a bathtub with a hot, so it's an old bathtub where you have the two nozzles. So this is hot and cold. We're going to add them together, and it's going to cause one job to be done, 1 over 1. All right, so the hot water faucet can fill the tub in 12 minutes. So hot is 12 minutes alone. The cold water faucet can fill the tub in 8 minutes, so 8 minutes alone. If both faucets are used together, how long would it take to fill the tub? So this is going to be our x on the top this time. We are looking for the together. We look for the LCD. We have 12 from that first denominator. And then we're going to say, 12. Does 8 go into 12? No. So can we find multiples of 12 that 8 will go into? So 12... If I'm thinking about this, the next number would be 24. Does 8 go into 24? Yes, it does. So my LCD is going to be 24. I can either make both fractions have that 24 for the denominator, just because we'll do it slightly different than we've done all the other ones. So we will get every denominator to be 24. So this will be times 2. Whatever you do to the bottom, you have to do to the top. 8 times 3 is 24. Do the top, and then 24 over 24. So do not forget that third fraction. So this time I have 2x plus 3x over 24 equals 24 over 24. I can cross multiply, and I can simplify first. So we have 5x over 24 equals 24 over 24. Looking at that, the 24s on the bottom could cancel out, or I could multiply both sides, cross multiply. So this is going to be 24 times 5x equals 24 times 24. I don't really want to multiply 24 and 24, so I've noticed that there's a 24 on both sides, so I'm going to divide by 24. 24. I know it looks kind of crazy. So I have 5x equals 24. Divide both sides by 5. And you get x equals 24 over 5. 5 goes into 24 4 times. So 4 and 4/5, which is the same thing as 4.8. And I could just say it's 4.8 minutes or 4 and 4/5 minutes. And that makes sense, because it's going to be faster than both of them if they're working together. If it was slower, why would you have both of them working together? So all of these are a good way of practicing rational equations where you can either get the common denominators. You do have to find the lowest common denominator in any sense of the ways, and then a bunch of different ways that you can solve those problems, whichever way works the best for you, looking at the different problems. But general formula is the together over alone plus together over alone equals one job being done.